With laws of logarithms. I'm going to be using the PowerPoint that's available on Blackboard. So if you want to pull that PowerPoint up as we go through the video, you can do so. I will be going over most of the examples, but you might see that I skip over a few, and that's so that you can work through those on your own. All right, so our lesson today is on laws of logarithms, and we did visit logs last unit. But our objective today is to give an expression involving a logarithm or an exponent. We want to apply some properties of exponents and logs to either condense or expand the expression as indicated. So let's review some of the properties of logs. So last unit, we were looking at this side over here. We talked about having, if we take a log with base a of 1, that's equal to 0. Log base a of a is equal to 1. Log base a of a to the x is x. And a raised to the power, so this is our exponent, so a to the power log base a of x is equal to x. So these are some of the properties that we reviewed last time. So let's just go through some of these examples. So log base 3 of 3. That's going to be equal to 1. Log base 5 of 5 to the power 4. So all of this basically undoes itself. So our answer is 4. We have base 2 to the power log base 2. And so basically this undoes itself, leaving us with 37. And then we have something that looks like this. So how do we get this? Well, if we know this part right here, we have log base 5 of 1, and over here it says if we take the log of 1, it's going to be equal to 0. So basically this is like 8 times 0, so the answer here is going to be 0. And then we have log base 2 of 2 to the third power, so this right here is all going to go away, so that's going to leave us with 7 times 3, so our answer here is indeed 21. All right. The same is true for the natural logs. So again, we have our natural log properties over here to the left. So let's apply those. So e to the ln, that's the same as saying e to the log base e of pi. So all of this is going to undo itself. So our answer here is indeed pi. This right here is all going to reduce. So that's going to leave us with 2 times 4. So the answer here is 8. And then the ln of e is just equal to 1. So we get 5. So now let's start with our first rule. These are rules that you're going to be required to have memorized for our assessment for this unit. The first one is the product rule. So when we have the logarithm product, what that means is, you'll notice down here we have log base b of a product. So we have x times y. So the rule is we can expand this logarithm by using the following property, and it says you'll have log base b of your first product or first factor, which is x, and we can expand that by using addition, and we end up with log base b of the second factor, which indeed is y. So this is our first rule. The same is going to hold true for the natural log. So here again we have the natural log of the product xy. So we can expand this by writing the ln of x plus the ln of y. Now I've used parentheses to show the input for the log. You don't have to have the parentheses here. You could just write it out, like for the first one, you could just write log base b of x plus log base b of y. And the same is true for the ln. You could write the ln of x plus the ln of y. All right, so let's take an example. So using the product rule, I want us to combine. So we want to condense this. So here we're going to use the law of logs to combine this expression into a single logarithm. Right now we have 3, and we want in the end to have 1 log. Since my base is 4, we know that's going to be common, and we want to condense this into 1 single log. So using our property, we know that addition reduces to multiplication. So let's take a look at the different factors. So remember, a few minutes ago we expanded into different terms. So now we're going to take these 3 terms and condense it into 1 term. So the log base 4 of x plus log base 4 of y plus log base 4 of x is going to reduce to log base 4 of x times y times z. Is this going to be your answer? Let's try another one. Here they want us to go in the reverse order. Here they've given you a single log, and they want you to rewrite this log so that it does not contain a product. So they want us to expand this product right here. So in other words, we need to create, it's going to be, so we're going to have multiple terms. And so how you can determine how many terms you're going to have is by looking at the number of factors that you have inside of your log. So let's focus on that for just a bit. So let's take a look at what's on the inside. And because I don't have parentheses here, maybe I'll add it just for organization purposes. So we have 1, 2, 3 factors. So that tells me that I'm going to expand this into 3 terms. So our first term is going to be log base 3 of 5. My second term is going to be log base 3 of x. And my third term is going to be log base 3 of y. Let's work on our second example. We have log base 2 of the product 4a. So again, looking at the number of factors I have here in my product, there are 2 of them. So that means I'm going to have 2 terms. And the first one's going to be log base 2 of 4. And our second one is going to be log base 2 of a. Now, we do want to be careful because our goal here is to simplify as much as possible. And using our rules that we saw before, the properties we saw before, we actually can reduce this log base 2 of 4. So you can either recognize that this is going to be log base 2 of 2 squared. And if we see it like this, this is just going to reduce to the number 2. Or you're more than welcome to use your calculator to evaluate that. If you're not sure, you can just punch this into a calculator and see that this will end up being a whole number or an integer where we can reduce. So that'll be our final answer. Now, revisiting up above, this one here, if you type this into the calculator, you will find that this will end up being a decimal. So this one is in its simplest form, so you may leave it alone. Our next rule is called the power rule. So here again, we have log base b of x to the power n. So you can think of this as just repeated multiplication. So this is related to our product rule in the sense that we have x getting multiplied by itself basically n number of times. So if we wrote all of those out, whatever number of times that we would have, and just keep on going and keep on going, we would have n of those. So there's a shortcut to expanding this. So basically what you do is you take the power of your exponent, so that number n, and we write that out front. And so it'll be n times the log base b of x. And this is our rule. The same is true for the natural log. So our natural log is going to be equal to, we'll take our power, we write it out front. So we end up with n times the ln of x. So this is our second rule that we need to have memorized. So let's practice a few with these. So using our power law of logarithms, let's rewrite this so it does not contain a power. So right now we're taking the log base 2 of 5 to the third power. So we do not want to have this power of 3 in here. So we want to eliminate that by taking that 3 and writing it out front. So we end up with the 3 times log base 2 of 5. And you always want to check to see, can I simplify this term right here? And if you're not sure, and how you can check without using a calculator is just look at 5 and say, can 5 be rewritten in base 2? And the answer is it can, but it's going to end up being some sort of fraction or decimal. But if you don't have that ability to see that yet, use your calculator and you'll see that this would end up being a decimal. So for this example, this is all we need to do. Now for our next example that has the square root, we have to remember that square roots can be rewritten as rational exponents. So the square root of 5 is the same as 5 to the 1/2. So now we're going to take our power 1/2 and write it out front. And we get 1/2 times the log base 3 of 5. And we are done.